Hello, and welcome everyone to this training video. My name is Joel Burley. I'm an escalation engineer with the US TAC team. In today's lesson, we will cover the architecture and configuration of Cisco's Jabber for VDI, also known as JVDI. Our agenda will cover JVDI terminology, what is JVDI, JVDI components, how to configure JVDI, and how it all works. I suggest reviewing the terminology, as these terms will be used throughout the video. I will not go over these individually, as many were covered in our first lesson, and the JVDI specific terms will be covered later in this lesson. These are here to provide you with a resource for reference. Up to this point, we have mentioned JVDI, but what is JVDI? JVDI is a software solution developed by Cisco to provide a reliable software experience in virtual desktop environments. JVDI's origin is found in a limitation identified in data center virtualization. Let's take a look at this limitation. When looking at a diagram for JVDI, you often see a diagram like this, depicting a hypervisor with its hosted desktops and apps. But in reality, the smallest VDI environment is much larger. Most VDI environments are hosting hundreds, if not thousands, of HVDs. This is where the aforementioned limitation comes into play. When performing a call from Jabber on an HVD, without JVDI, the call setup signaling and call media must traverse an unoptimized network path. JVDI fixes this issue by offloading the call setup and call media to the thin client machine. This allows us to bypass the delay, jitter, and packet loss often seen in virtualization environments. Now that I've explained why we use JVDI, we will move on to the components used by JVDI. As with previous lessons, we will start on the thin client. This is where the JVDI client software is installed. Next, we move to the HVD, where both Cisco Jabber and the JVDI agent are installed. From here, we move to our unified communication components, starting with Expressway Edge and Expressway Core, which JVDI uses for mobile and remote access services, also known as MRA. It should be noted that JVDI can be implemented without MRA if only used on an organization's internal network. Our next component is the Cisco Unified Communications Manager, also known as CUCM. JVDI leverages CUCM for its UDS, TFTP, CTI, and SIP services. Next, we have Unity Connection, whose VM REST and Jetty services are used by Jabber for voicemail. And last, we have IM and Presence, which is used by Jabber to provide instant messaging and presence services via the XMPP protocol. So far, we've discussed what JVDI is and what its components are. Now let's move on to its configuration. The JVDI UC configuration is very similar to standard Jabber, with the addition of a few steps that are essential for JVDI to operate. We start the configuration by verifying that every JVDI user has a valid CSF device with a line configured. Next, verify that both the CSF device and line have Allow Control of Device from CTI enabled. Note, this should be enabled by default. While verifying the CTI permissions on the CSF line configuration, we should also verify that the CUCM end user has been associated to the device's primary line. After verifying the CSF and line configuration, we move to the CUCM end user configuration. Start by assigning the standard CTI enabled role to the JVDI CUCM end user. While in the end user configuration, add the CSF device to the controlled devices. This is very important as the CSF device must be assigned as a controlled device, or CUCM will not allow Jabber to CTI control the CSF device's line. We should also verify that the CUCM end user's primary line has been set. Next, verify which service profile has been assigned to the JVDI CUCM end user. Then verify that the CTI servers have been assigned to that service profile. Now that we've covered the configuration, let's move on and review how JVDI works. The process begins from the thin client, the user opens a session to the VDI Solutions web UI via the web browser. In this example, we have connected to a Citrix storefront web UI. From here, we select the HVD we would like to use. Once selected, the connection broker will be engaged to find the user in HVD. The connection broker reaches out to the hypervisor and verifies the resources available for that user. Once a resource has been identified, the connection broker collects the connectivity and configuration details from the virtual broker agent running on the HVD. This information is then passed back to the virtual broker client on the thin client machine. The virtual broker client then uses this information to securely connect to the HVD. This is a good place for us to stop and talk about the JVDI installation order, as it is dependent on the virtual broker client software. JVDI must be installed in a specific order or it will not function. On the thin client machine, the virtual broker client software must be installed before the JVDI client software. This is because the JVDI client adds itself as a third-party integration to the virtual broker client configuration. The HVD also requires a specific installation order. The JVDI agent must be installed before Jabber, as Cisco Jabber relies on the JVDI agent for VDI-related dependencies. Now that we've gone over the installation order, let's get back to how it works. We left off where the virtual broker client had securely connected to the HVD. During this process of securely connecting, the virtual broker client calls the JVDI client process called vxc.exe. Moving over to the HVD, when the Jabber process is launched, it also calls two other JVDI agent processes. One is called the HVD agent.exe. The other is the vxc settings.exe. At this point in the process, the virtual channel is up, and all the JVDI processes have started. But what does that mean? The virtual channel is formed when the virtual broker client securely connects to the HVD. This process is no way dependent on JVDI or any Cisco service. The virtual channel will always be formed by the virtualization vendor software that is in use. So we can think of this virtual channel like a conduit or a pipe that is formed between the thin client and the HVD. When the JVDI processes are launched on the thin client and the HVD machine, they use the virtual channel to communicate with each other and set up streams. These streams are unidirectional and either provide read or write capabilities. They carry information like device and accessory information, config details, version information, telemetry data, and are even used for collecting logs. Okay, let's move on. During the time that the JVDI processes are setting up the read and write streams, Jabber isn't just sitting there idle. Jabber initiates its standard login procedure, including Cisco UDS service discovery, home cluster lookup, authentication, and end user and device config retrieval. Jabber then takes this information and caches it. Jabber then takes the cached information and provides the Jabber user information, voice service domain, credentials, CSF device name, and device security information to the JVDI client via the previously set up streams. The JVDI client uses the domain information provided by Jabber to perform service discovery. In this scenario, the JVDI client would attempt to resolve the Collab Edge DNS SRV record, as this JVDI connection is over MRA. Once service discovery is complete, the JVDI client retrieves the CSF device configuration, application dial rules, and directory lookup dial rules using CUCM TFTP requests via the expressway. After retrieving the CSF device configuration, the JVDI client begins the CSF softphone registration process. In this scenario, the JVDI client performs the SIP registration process over MRA. Once the CSF device is registered, Jabber attempts to CTI control the registered CSF device. It does this by establishing a CTI control session between the Jabber client on the HVD and the UCM CTI manager service. When completed successfully, Jabber will gain CTI control over the CSF device. This allows the Jabber client to make calls by controlling the thin client CSF device that is registered over MRA. It should be noted that Jabber on the HVD still operates as normal for other services like voicemail and IM presence. VMRest and Jetty are still used for voicemail services, but the connection doesn't use JVDI. Jabber establishes its session directly to the Unity connection server. This also applies to presence and messaging in Jabber. Jabber on the HVD establishes its XMPP connection directly to the IM presence server. Once this is complete, Jabber will show the softphone as connected and registered. Jabber users are now ready to make calls via CTI control of the thin client registered CSF device. In today's training, we covered what JVDI is, its components, how to configure JVDI, and how it all works. I would like to thank you for your attention, and I will see you in the next one.